Hello everyone, welcome back to the course Financial Mathematics for Actuaries. We are learning the loan amortization principle. I believe you have already learned in this week the loan amortization schedule and how to compute the loan outstanding balances and also how to compute the loan installments. Today we are going to discuss the numerical examples in various scenarios to compute the loan balances and loan installments or installment payments. Let us do that today. Okay, so let us see this problem. This problem says a loan of 5 lakh rupees with a level payment made at the end of each of the next 5 years with an effective annual interest rate of 7%. Now we need to compute the annual payment and also we need to compute the outstanding balance on the loan immediately after the first payment. So we can use the formula that we have understood or learned in the prospective method to proceed this. Okay, so let us do the solution for part A. So what we have here in the problem, we have the loan amount L, okay, that is 5 lakh rupees, which is also known as the initial loan balance, that is B0, and we have the interest rate and we have the N. So N is equal to 5 and I is equal to 7%. Let us now compute the A. So we can use the formula which says A is equal to L upon A angle N at I. Okay, so this says like, so N is 5 and I is equal to 0.07. So we need to compute this first we compute this and then again we will compute this. This will give us like the present value interest factor for annuity, okay, for 5 payments and I interest rate, that is 0.07, which is amounted to be is 4.1002. Okay, so this then the final answer will be 1,21,945.27. This is the loan installment amount. Okay, this is the installment amount, out of which, okay, you already understood how much will go towards the interest payment and how much will go towards the principal payment. Okay, as we know that you can simply compute the loan the interest amount, okay, and it's from this, in fact, the uh, total amount that will go towards the interest payment is 35,000. Okay, 35,000 will go towards the interest amount and rest will actually go towards the principal payment. Okay, principal amount, that is 8,6,945,945.27, okay, rupees will go toward the principal reduction. Okay, this is go toward the principal and this will go toward the interest due, right? So this is the first part of the solution. Let us now have the second part of the solution. What is the second part of the solution? Again we have the same thing, that is L is 5 lakh and N is 5 and I is 0.07. So we need to compute the outstanding balance after one payment. What is the outstanding balance? You need just, here the principal has earned the interest for 1 year. So we have this, okay, that is 5,35,000. Okay. So B1 can be simply computed as this amount minus, okay, the balance amount what we had seen here. Okay. So this one is your total interest payment. Okay. Here, that is of the initial loan balance, that is 5 lakh multiplied by 1 plus I. Okay, that will give you this amount, and then this is the installment amount. So this is the total loan balance. So we will have B1 is equal to this one. Okay. Okay. So now look at this problem. Okay, we have two more problems to solve here. Okay, the first problem says a loan of rupees 1 lakh at a nominal interest rate of 8% compounded monthly is repaid in 4 monthly payments starting 1 month after the loan is made. So the first two payments are in amount X and the last two payments are in the amount 2x. Construct the amortization table for the loan. So here we have to understand the problem first. Okay. So the loan amount is 1 lakh rupees. Okay. The interest for annum is 8% and the loan has to be repaid within 4 months in the 4 installments. So first two installment with the X amount and the second 2 months will be the 2 times X amount. Okay. So we have to construct a loan amortization table, okay, for this 4 payment scheme. Okay. Let us do that. One. And the second problem which says here, okay, like a loan of 40 lakh rupees was to be repaid over 20 years by monthly installment of an annuity immediate at the nominal rate of 5% per year. Okay. After the 24th payment was made, the bank increased the interest rate to 5.5%. Now here initially the interest rate was 5%. Okay. Now the bank increased the interest rate to 5.5% after the 24th payment. So if the lender was required to repay the loan within the same period, how much would be the increase in the monthly installment? That is the first question. The second question is, if the installment remains unchanged, how much longer it will take to repay the loan? Okay, let us solve these two scenarios, okay, using the formula what we have learnt in our loan amortization principle session. Okay. Okay. So let us compute the first problem. Okay, that says a loan of 1 lakh rupees has to be repaid within 4 installment. The first two installment is in the X amount and the second two installment is 2 times X amount given the interest rate. So how to do that? Now the interest rate is what? So what is given here for us is like I is now 0.08, okay, now divided by 12. So 4 month we have to, we have to now compute for this monthly interest rate, that is it will come around 0.0066. so I is now, okay, 0.0066. We will consider this I instead of this 0.08. So here what we have to do is we have to treat the repayment of the loan as payment of X. So now I will write it here, treat the repayment of the treat the repayment of the loan as payment of X as payment of X, or simply we will take like the way it is given, payment of X, okay, each of the month, and extra payment of X in the last 2 months, okay, each of the month, and we will treat the extra payment of X, payment of X in last 2 months, in last 2 months, okay. So how to do that? Let us now compute the amount here, okay. So we need to compute the loan amount, that is L. So what we have to do here? We have to set L is equal to X of, okay, A angle, that is the N, that is 4, and the interest rate, which one we will use? We will use the 0.66 plus, okay, X V square, okay, sorry, I have to write here A angle 2, and the interest rate here, okay. Now we have to compute the process, okay. So this can be computed as, okay, L is equal to, so what is L here? L is 1 lakh rupees, 1 lakh, okay, and then we will do that. We will compute this as this one will be 3.9349. So you can put here, plus we can put it like as it is, okay. First we will put as it is, V square A angle 2 at 0.0066, right. So let me now compute this first, okay. Rewrite this here, right. So 3.9349 X plus we will have here, that is this V square is what? V square is 1 upon 1 plus I. So I will simply write 1 plus 1, sorry, 1 upon 1 plus I to the power 2, okay, and then I will write a to 0.0066, okay, and then I can write it this, sorry. So this is the X, okay. Now we can compute this one using the same principle here, okay, and these are, and again we can easily compute this as this. So 3.9349 X plus what is this? This amount will be 0.9869, okay, multiplied by, okay, we will have here, that is multiplied by again 1.9803.9803 x, okay, which can be simply written, okay, 3.9349 x plus we will have 1.9543 x, okay, which will be equal to 5.8892 x. And now we can compute the x as equal to 1 lakh by 5.8892, that is equal to 16,980.24. Okay, so x is now 16,980.24. At t is equal to 1, a payment of A1 is equal to 16980.24 is made, right? Now we need to compute the following. We need to compute the interest amount for first payment, the interest amount, amount for the first payment, that is we need to compute I1. We need to compute I1, which is simply B0, okay, time I. So we can have here that 1 lakh rupees, okay, multiplied by this 0.0066, which is simply 660 rupees, okay, and the principal repaid in the first period, okay. So the principal repaid in first period is therefore A1 minus this I1, okay. So simply it will be 16980.24 minus 660, which will give us the amount, that is 16,320.24, okay. So from this, now we can compute the outstanding balance at the end of first period, that is B1 is equal to B0 minus this one, that is A1 minus I1. So simply we will have 1 lakh minus 16,320.24, which will give us a value, that is 83,679.24. 6. Okay, so this is the total outstanding balance in the first period. Okay, and the initial amount we know is 1 lakh rupees. The interest amount, total interest will be 660. Okay, and the principal repaid is therefore 16,320.24. Okay, 0.24. So now we can easily construct the loan amortization table. So put all the value in a table and then we can construct the loan amortization table. Let us do that. So if I need to construct the table here, let me construct it here in this way. Okay, so I have period T, I have, okay, I need to compute the payment and the interest due, okay, and the principal repaid, and then we will compute the outstanding balance. Okay, so put all this. Now initial amount at the time 0 we have nothing. Okay, and then we have 1 lakh rupees. Okay, and what is the first payment? First payment we have computed as 16,980.24. So 16,980.24. Interest due is 660 and the principal repaid is 16,320.24. Now we will deduct this one, okay, this one from this one, we will get this amount, that is 83,679.76. Now in the second period you should do the similar computation, okay, similar calculation, and you can proceed to get the value as it is. So initially the first two payment is similar, so we will have 16980.24. okay, and using the same procedure, okay, we can compute this as this the interest due is equal to 5, that is the interest amount of this one. So you will have here 552.29, okay, and then you deduct this amount from here and we will get 16,427.95, and the loan outstanding balance you will get in period 2 is 67,251.81. okay, so now we have to compute the third period and the fourth period. So third period is what? Third period is double of x amount, that means double of this amount. So just multiply 2 here in this and you will get 33960.48, and the rest of the thing will actually proceed, proceed as follows. So we will have here, using the similar principle, we will get 443.86. okay, so from now this minus this one will give us 33516.62, and then the loan outstanding balance, therefore this minus this one, so it will become 33,735 735.19. Okay, and the same amount will be paid in fourth installment also, so I will write the same amount here. Okay, but in the interest due is now 222.65 and the principal repaid is therefore 337.83. So this is almost this one and this one are same. So again it will very so the outstanding balance will be only this one. This is rounded up to 0 and you can get the loan amortization schedule. This is the loan amortization schedule that is required. So now we have understood that how to compute the loan amortization table even if the installment payments are different, in which case we have understood that the installment initially was X amount and later on the installment was doubled. So now let us go back to the third problem here, which says a loan of 40 lakh was to be repaid over 20 years by monthly installment of an annuity immediate at the nominal rate of 5% per year. After 24th payment was made, the bank increased the interest rate to 5.5%. Now, if the lender was required to repay the loan within the same period, how much would be the increase in the monthly installment? That is the first question. Okay, and the second question is, if the installment remain unchanged, how much longer it would take to repay back the loan? Okay, so now let us use both the retrospective method as well as the prospective method, because that we have already understood earlier, and we can see that they are actually very similar answer. Okay, so for this model we know that we know that we know that A is equal to L upon A 9. Okay, or in this case we will have 40 lakh. Okay, so 40 lakh divided by this A. Okay, we will write here, that is A of 240 and then this 5% is divided by 12. Okay, so this will be amounted to something like 0.00416. Okay, so using this you can easily compute, that is okay 40 lakh divided by 151.626, okay, which will be equal to 26,000, sorry, which will be equal to 26,380.679. Okay, So this is the installment amount we have computed. Now let us find the loan balances for 24th payment. Okay. And for B24, okay, we have to compute A, that is 240 minus 24 is 216, with the interest rate that we have just computed is 0.00416, which then you can easily compute that A is what? A is 26,380.679, okay, multiplied by, we will have A angle 216.0.00416. So we can now compute it as like 26,380.679 multiplied by, we'll have here, you can now use the formula for interest rate sorry, use the formula for present value interest factor for annuity given n is equal to 216 and I is equal to 0.00416, and we will get that, we will get 142.32 or 0.3280. We can use the calculator to get this value, okay, and then upon multiplying this we will get 37 lakhs 54,712.127, okay, 0.127. This much is the outstanding balance after 24th payment. This is the prospective method. Now you can use the retrospective method, okay, to get exactly the same value. This value may change a little bit because the decimal points, okay, we are considering here is actually only 3, and therefore the value may change a little bit, but you can get exactly same value if you will use the retrospective method. Okay, so by the retrospective method, then I will compute it here. So using the retrospective method, we can compute for B24. We can compute for B24 as this, that is, we have here our 40,000, 40 lakh 405 time 1 plus I is equal to 0.00416, okay, to the power, we will have 24 minus, we have here that is the 26,382.699 multiplied by, we will have here, that is the future value of this at S angle n is now 24, and that is 0.00416. Okay, so this formula, okay, so now you know how to compute this, right? So S angle n at I can be computed as 1 plus I to the power n minus 1 divided by I. So using simply this rule, we can compute this as, now this one is computed to be 1.1047. So 40 lakhs multiplied by 1.1047, okay, and then minus we will have here 26380.699, okay, multiplied by, we have got this, after calculating this future value, we will get, that is 25.183, right? So we can easily compute it as 44,188,00 minus 6,64345.1429. Okay, upon solving we will get, again it is around like 37 lakhs 54,454.85. So these are, like similar. The value is little bit changed because of the decimal, but you should get the exactly same value. Okay. So now let us compute the problem that are asked here. So what is the problem? First problem is to compute the installment amount after the increase in the interest rate. Okay. So the revised monthly installment is now computed as, okay, we will simply compute. You will take the in value, that is the installment amount, that is 37,54,712.127 or 127 divided by the present value interest paid per annuity, that is given 216 with the new rate of interest, that is 0.055 divided by 12, which can be, like computed and written as, this is 0.00458, right? So now let us use it here to compute. So I will have here again 3754 712.127 divided by, okay, now we will have 136.968. okay. So upon solving we will get a value, that is 27,413.060. You can use your calculator to get the value. So this is the new installment amount. So what is the initial installment amount we had? The initial installment amount we had was so what is the increase? Now the installment is now increased to the installment amount. Okay, I will write this amount. The installment amount is increased to what? Increased to what? We will have here 1032.361. This is simply, you can get this value as, you can just deduct this initially, that is 26,380.699. okay. So what is the increase now? So 1032.361 rupees increased in the installment amount, okay, that the candidate has to pay. Now let us compute the second part. What is the second part? The second part, we need to compute how much time it need to complete the loan if the rate of interest is now changed and the installment is remaining the same. Okay. So in this case, let M be the remaining number of installment, M be the remaining number of installment, and if the amount of installment remain unchanged, if the amount of installment remain unchanged, okay, then we can compute the total amount as this one, A angle M at the new interest rate, that is 0.00458, okay, which is equal to, okay, now we can rewrite this as A angle, M is now what? M is now 216 and I is therefore, okay, the old interest rate 416, which we have already computed as 142.328. So now we need to solve for M. Now need to solve for M and we will get the total number. Okay. So let us now solve for, okay. So replace the value here as we will rewrite the formula for this one. This one, the formula is like 1 minus 1 upon 1 plus the interest rate, that will become 1.00458 to the power M whole divided by the interest rate, that is 0.00458 is equal to 142.328. Now this can be written as simply the 1 minus 1 upon 1.0045 458 to the power M is equal to 142.328 multiplied by 0.00458, right. So this then can be equal to what? That is 0.6518. So we will have here 1 minus 1 upon 1.00458 to the power M is equal to 0.6518, and therefore we can have 1 upon 1.00458 to the power M, okay, is equal to, we will have here, that is 1 minus this one, that is 1 minus 0.6518 will become 0.3482. Okay, and now you can rewrite this as, like, or we can just simplify it as 0.0458 to the power m is equal to 1 upon 0.3482. We can say, or 1.00458 to the power m is equal to, we will have 2.871. Okay, now you can apply the logarithmic rule here and you can get the value, and therefore using the logarithmic formula we will have add log of 1.00458, okay, over m with log of 2.871, or we will have m log of 1.00458 is equal to, simply we will have log 2.871. Okay, and then therefore we can compute m is equal to log of 2.871 divided by log of 1.00458. Okay, now use your calculator to get the log of 2.871 and log of 1.00458, and you will get the value that we have here is 1.0546. okay, 1.0546 divided by 0.0045 and then we will get 234.3. okay, so what we have got here, m is equal to 234. This 234, okay, is now compared with the initial. So now what is the total or time or total month that is required to repay the loan completely? That we can get it by simply, you can have simply we'll have this 234 minus 200, okay, 16, we will get around 18 month. Okay, so it take around 18 month, right? So the answer is it take around 18 month more to repay back the total loan. Okay, so I think you have now understood how to compute the loan amortization. Okay, that how to compute the total outstanding balances, how to compute the installment amount, even if there is varied interest rate, even if the bank change the interest rate. This type of problem is very common in the uh, real market situation, where sometimes the bank initially come up with a loan scheme with a given interest or with the stated interest rate, and after some period of time that interest rate may increase. So at that time actually you need to compute or recalculate the total installment amount, and also the total time period to which the loan is to complete fully. Thank you.